Alright, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, student.
Good afternoon, sir. Sir,
How are you today?
I'm fine. Alhamdulillah, fine.
How was your holiday, Independence Day? Is it good?
Yes. Good. Yes, good.
Did you join any competition designed by OSIS? Did you join competition made by OSIS?
No, I didn't.
How many competition OSIS did yesterday? Do you know the competition that organized by OSIS? Nobody know in the class, so nobody joined the competition for the Independent Day. For example, I saw that in the Instagram there is a competition about making a sticker. I think I asked for the other class 10A. They said that there is competition of making sticker, WhatsApp sticker, isn't it? Do you know this?
Yes, I know.
But nobody joined.
We are joined.
Join it. Which one? What other competition they made? Sticker competition. What else?
Sticker competition.
What else? Quiz, I think. I saw that there will be quiz competition, isn't it? Okay, good. I think that you should be active here in OSIS organization. They will make some program for you. So instead of you are only learning in a Zoom learning lesson, but you have to be active also in some non-academic activities. I think it's just very refreshing for you, and it's important. Yeah, during the online learning, you need more refreshing because every day in very long time you have to sit in front of the screen. So maybe it is frustrating and it can make you stress. So that's why you need some activity other than academic. So I think OSIS already planned some of the activity and they did it for the Independence Day. Maybe in the following days there will be also one holiday related with the New Year's, Islamic New Year's. Maybe they will also organize some of the activity. I think you should join the activity. Okay, let's start the lesson for today. So as usual, before we start the lesson, let's pray first. Pray, begin. Amen. Okay, as usual, please go to your WhatsApp group and go to the description, group description. There's a link for the attendance. Please, everybody, you can you can check or you can fill the attendance for today's lesson. And also, I can give also the attendance here in the chat room so everybody can fill from this chat room also. Okay, please fill your attendance. Now 14 students here in the classroom. Anybody absent today?
No, sir.
Yes.
Nothing.
Everyone is here. Good. Okay. Okay. Let me share my screen. Now, can you see my screen?
Yes,
Okay.
sir.
Good. By the way, before I start the lesson, because my connection is not good and I couldn't writing if my video is on, so I have to close my video so I can do writing in my slide. Okay, so just you listen to the slide. So I'm going to close my video. I'm sorry about it because the connection is not good. So it's difficult for me to write if my video is on. Okay, guys, so this is our lesson, chemistry lesson 14. Yeah, it's video conference. Today we're going to have two lessons, lesson 14 and lesson 15. Lesson 15 will be in the Google Classroom as usual. So what we're going to see today, okay, we are going to start with the review. So we did this. We're going to start with the review here. We're going to review what we already show last lesson. So let me use this green color. Okay, what we saw last lesson, I think everybody was remember we were talking about history of atom, isn't it? We are talking about this. Okay. And do you remember who is the man who is first made the theory about the atom? What is the name?
John Dalton.
Yeah,
John Dalton's.
it was John Dalton. It is the first man who made the theory about the atoms. What he said about the atom, John Dalton said that the atom is just like a ball without any charge. John Dalton, he was not be able to talk about the positive, negative charge of the atom. Just talking about the atom in the elements with its properties. Yeah, the element with the same. Uh, the element have the same type of the atoms. Different element will have the same. Different type of atoms. And also, when there is a chemical reaction, a atom is not destroyed, yeah, just it is reformed or it is changing, it is combined or separating the atom during the chemical reaction. So mainly Dalton is talking about the atom. It's just like a ball, it's like this, yeah, without any positive or negative charge. So it's a very what simple definition of atoms. So this is the first one, and then after that the second one, do you remember which scientists said about the history of the atom? The second one, it was J.J.
J.
Thompson.
Thompson.
J.J. Thompson.
Yes, J.J. Thomson is the second scientist who are made a theory. Now J.J. Thomson is familiar with what? It is with electron, isn't it?
Electron.
Yes, J.J. Thomson is the one who invent the electron. Do you remember what is the name of the experiment that made by J.J. Thomson?
Cathode ray.
Yes, it was
Cathode ray.
rays experiment. Yet by doing this experiment, J.J. Thomson found the electron, and then he made one theory of atom. He said that atom is like a spherical. Again, it is like John Dalton. It is spherical structure, and then there are electron or negatively charged distributed in that spherical positively charged structure. So it is like this. Yes, it's like plum pudding. Yeah, John J.J. Thomson say about this one. And then after that, what we said after that, somebody is writing in the chat. Let me check. You cannot see the slide clearly. How about the others? Can you see the slide clearly?
No, not
No, sir. I
clearly,
can. It's
sir.
blurry.
Blurring.
It's kind of blurry.
Yes, blurry.
Everyone is blurred? Or anyone
Yes.
can see clearly?
Yes, sir. It is blurry, sir.
It's blur.
Sir,
It's blur.
But can you see what I wrote here? History of atom. Can you see it?
Yes. Yes.
No,
But
I
blur.
can't see.
But blur.
I can see anything, sir. I just can see preview. Okay.
Maybe because of the connection. That's why. But is there anyone can see the history of atom? The writing history of atoms?
I can see it, sir. I
You
can
can
Yes,
see
see
I can
it.
see it.
John Dalton, J.J. Thomson, I wrote here. You can see it, right?
Yes.
No, I
Yeah,
can't.
because
I can't.
for the one who couldn't see it, maybe the connection is not good. That's why you cannot see it. Okay, let's continue then. So it is a cathode ray experiment. After cathode ray experiment, do you remember there is a Millikan experiment, isn't it? Millikan is talking about the charge and the mass of the electron, right? The mass and charge of the electron are found by the Millikan. Do you know, remember the experiment that Millikan did? It was what? What is the name? The experiment? Millikan? Anyone? Remember? What is the name of the
No.
experiment? It was oil. Oil what?
oil drop.
Oil drop experiment. It is the experiment they did by the Millikan to find out the mass and the charge of the electron. Good. Okay, after J.J. Thomson made his theory, and then after that, who made the theory? The third one, Millikan. By the way, Millikan didn't make the theory. Millikan just found the mass and the charge of the electron, but he didn't make any theory. The third one, do you remember?
Rutherford.
One, it was Rutherford theory of atoms. Okay, Rutherford. What is important in Rutherford? What he found actually?
Nucleus.
Nucleus.
Okay. Important
In
things in the Rutherford is the invention of nucleus.
atom model.
Okay. So the invention of nucleus is the important in Rutherford. Rutherford said that if I want to draw the model of Rutherford, there is a positively charged, in the middle, and it is we call as a nucleus, isn't it? And then after that, electrons are moving around the nucleus. Electrons are moving around the nucleus. So it is like this, the Rutherford atomic models. So after he found the nucleus, later on, this positively charged, the positively charged here in the middle. Let me use a different color. Okay. This positively charged in the middle here, later on, it is called as proton, isn't it?
Proton.
Okay. Who found the proton? Anyone remember?
William Thomson.
Are you sure? Proton invented by Eugene Goldstein. Yeah, it is invented by Eugene Goldstein. Yeah, proton. Okay, after proton invented, later on, neutron also invented. Yeah, later on, yeah, but a different man found the neutron. Do you remember who found the neutron? Okay, we were talking about this one last week. Neutron. Let's remember who invented the neutron. Chadwick. Do you remember? James Chadwick. Do you remember this one, guys?
No.
We were talking about this one last lesson. Let's see. This one. Do you remember? James Chadwick. It is about this neutron. Alpha rays, there's a paraffin wax, the canal rays, which is positive. This is Eugene Goldstein. Yeah, this is the discovery of proton. Yeah, please check again about this one in the video. I upload already the video, so you can see again what we already learned before. Okay, after Rutherford, do you remember what else? Who else? Rutherford, John Dalton, J.J. Thomson, Millikan, and then Rutherford, and then Eugene Goldstein for proton, and Chadwick for neutron. After that,
Bohr.
it is Bohr's atomic models, isn't it? In Bohr's atomic model, we were talking about what? We have nucleus positively charged,
Nucleus.
and then we have electron moving in the orbit, isn't it? Electron moving in the path, which is orbit. So like this, okay? So this is the Bohr's atomic models. After that, after Bohr's atomic model, then the Bohr's atomic model then revised by the last models. Revision of Bohr's atomic model, it is called what? It is called modern atomic models. Yeah. So this is the model that we use until now. Modern atomic models. So this is the revision of the Bohr's atomic model. Let's see back again the lesson. When you see this one, yes, this Bohr's atomic models, right? The one which is in the middle, we have nucleus, and then electron moving in its own fate. We call it an orbit, right? And it is modern atomic models, or sometimes it's called as an electron cloud models. The other name, yeah, electron clouds models. Okay, so sometimes it's called as a modern atomic. Modern atomic models, or the other name for this one is electron cloud models. Let me write here electron cloud models, so you can remember this one, electron cloud models. So in general, this is the history of the atom, guys. So in general, it's like this. We have John Dalton, we have J.J. Thomson, and then Millikan with the oil drop experiment. He found the mass and the charge of the electron. J.J. Thomson found the electron by using the experiment called as a cathode ray experiment. Rutherford, found the nucleus. By the way, what is the name of the experiment that done by Rutherford? This experiment. Do you remember? It is called as a gold foil.
Gold plate. Oh,
Gold foil experiment. Okay, it is called as a gold foil experiment. By doing this gold foil experiment, Rutherford found the nucleus, and then after that, Eugen Goldstein find the proton, and then Chadwick find the neutron. After this one are found, and then Bohr made its theory about the atom, which is in the middle we have nucleus which is positively charged, and then electron here. There are electrons here moving in the circular plate or orbital. Yeah, this is what Bohr said, and then after that, this Bohr's atomic model is revised by the modern atomic models, or is called as the electron cloud models. Okay, guys, what we are going to see today, so this is just the review. What we are going to see today, we are going to see these two: Bohr's atomic model and modern atomic models in detail, a little bit detail, because the other theory, John Dalton, J.J. Thomson, Rutherford, is not being used anymore because it is too simple, too many weakness in this theory. So the theory that are used now is more about Bohr's and modern atomic theory. The theory that used up to now by the scientists is this theory. It is based on the Bohr's atomic models, and then it is revised by the modern atomic model or electron cloud models, or the other name for this one, maybe you heard about this one, sometimes it is called as quantum. The other name for this one is quantum atomic models. Yeah. The other name for the electron cloud models or the modern atomic theory, it is quantum atomic models. So we are going to see these two in detail. Let's continue to the next slide. Yes, Bohr's and atomic model theory, modern atomic theory. Still, we are going to learn about the history of the atom. Now we are going to start with the first one, Bohr's atomic model. Can you see the slide?
Yes, sir.
Yes, sir.
It is Bohr's atomic models. There are some postulates that made by Bohr's. The first one, Bohr said that electrons are found in certain place, so-called energy levels. It is called as energy levels, or it is, the other name are shell. It is called as a energy levels or shell around the nucleus with certain energy, So what Bohr say, as you can see here, the picture is like the picture that I drew before. There is in the middle here, there is a nucleus here in the middle, which is positively charged, is contained of, we know that in the nucleus there is proton and neutron here. And then electrons are moving in the spatial phase, or spatial orbit, let's say this is the electron are moving here. And Bohr give the name for these ways. Bohr give the name for these ways where the electrons are moving. What is the name for this? The name are called as a shells. So this is shells, this is shell, this is shell, this is shells. We have 4 shells here. Shell number 1 here, shell number 2, shell number 3, and shell number 4. The other name for shell yeah, it is also called as energy levels, as it's written in the slide. It is called also energy levels. Why it is called as also energy levels? Because every shell here or every ways where the electron are moving have a certain energy. Have a certain energy. Ada energi yang khusus untuk setiap shell. Ya. So this first one is the first energy level with certain energy, the second energy level with certain energy, and so on. So every shell will have a certain energy. Okay? And in this shell and in this energy level, you can find the electron. Electrons are found in there. So you will not find the electron in other place. You will find that the electrons are on those shell. Okay, this is the first one. Any question about this? Is this clear? This is important. This is the basic of the atom, yeah, that we understand or that we use today. The theory, the basic theory of atoms. Okay, number one. Is it clear? Can we move?
Yes.
Okay, let's move to the second one.
Yes,
The
sir.
second one, electrons move in its stationary state. So here the most important one in the second one is it is stationary state in circular phase. So this electron, this one, the electron are moving here, like this one moving in a stationary state. It means that the place is not changing. It's like an orbit, yeah? Orbit is moving in its state, in its stationary state. So it will not changing from one place to another place. And this is called a circular. Then this movement is a circular fate. So the movement will be circular fate. Yeah. So that's why when you see this one, we have energy level which is circular fate here because the electrons are moving circular. Okay. It is clear for number two.
Yes.
Okay. Let's move to number three. This is also important. We have four postulate, yeah. Number three, when an electron falls back, this is important, falls back to a lower energy level from a higher one, falls back artinya apa ini?
Mundur.
Mundur. Jatuh.
Ya, mundur.
Falls back. Falls.
Jatuh kembali.
Jatuh kembali.
Jatuh kembali.
Back. From a higher energy level to a lower energy level. So jatuh falls from the higher one to the lower one. So take a look at this electron. Now I have electron here in the energy level number 3. Yeah, we have 3 energy level. This is energy level number 1. This is energy level number 2. This is energy level number 3. Now electrons are moving or not moving, falls back from energy level number 3 to energy level number 2. It is falls back. When it is falls back, it emits a quantum of light. What does emits mean?
Mengeluarkan.
Memancarkan.
Memancarkan, good. So it's memancarkan quantum of light. So there will be light. So this is, as you can see here, this is a light. Yeah, it will emits a light, which is a kind of energy. Actually, light is a kind of energy. So the energy will be emitted, dipancarkan, when the electron are falls back from the higher energy level to the lower energy level. And the reverse is also possible. The reverse is also possible. Electron also can move from the lower energy level to the higher energy level. When it is happen, now the word not emits. It will, if here energy is emits, if from the higher to the lower energy is emit, from the lower to the higher energy will be what? What is the opposite of emit? Anybody know? In bahasa, what we call this one? Memancarkan, lawannya? Nobody know? It is absorb. Yeah. So we have two type of energy here. Sometimes energy can be emitted or energy can be absorbed. When energy is emitted, so it will make the electron jump from the higher energy level to the lower energy level. When the energy is absorbed, so the electron will jump from the lower energy level to the higher energy level. It is clear? Guys? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Can we move?
Yes, sir.
Yes, sir.
Okay, now we move to number 4. Number 4 is the possible stationary energy level. We know that we have an energy level, yeah. We have energy level, and its stationary energy level have a name, yeah. It have a name. The name is symbolized by letters K, L, M, and O. So please be careful in here. The letters are not starting with A, but it's starting with K. So the first shell here, yeah, the first shell, it is called as a K shell. Yeah, the first shell, it is K, not A. Yeah, second one L, M, N, and so on. So it is second one, it is will be M, yeah, and then N, and then O, and then so on. And also sometimes it can be also denoted by numbers. If it is using a numbers, then you have to use the small n here to denote the numbers. The numbers starting from 1. Yeah. So for shell K here, yeah, for shell K here, it means that the n, small n, is equal to 1. For M here, okay, for M, n equal to
2.
2.
and so on. For N, n equal to 3. For O, n equal to 4. So either you can use this capital letter K, L, M, and O starting from K, or you can use number with the small letter n in front of n1, n2, and 3 to give the name of each cell. So if I'm saying you K cell, you will understand that K cell, it means that it is the first energy level or the first shell here in here. If it is, I told you L shell, it means that the shell in here with n equal to 2 and so on. So this is just the naming of the shell. So you will understand this one. Okay? Is it okay?
Yes.
Yes, let's move. Okay. So it is about Bohr's atomic model. I told you that there are 4 things in Bohr's atomic models. Yeah. is electron found in the energy level or shell, and then the electron move in circular fate, and then the electron can falls back with energy emitted or can jump to higher energy level with absorbing energy. And the last one, the naming of the shell by using K, L, M, and O, or N equal to 1, 2, 3, and 4, and so on.